Let's look at a common example. Let's assume we're building something like a new Amazon. So we'll look at how we would build it as a monolith, and then what happens if we break it to microservices. So let's look at, let's start with, betteramazon.com. We're building a monolith. So what will it need? It will need database. And we're just going to do a very simple transaction. We're going to create an order, and we're going to fulfill this order. So we're going to create an order and then create a shipping record. And let's just assume this all just takes care of the whole order. Now, of course, things get more complicated, but in this simple example, we'll be able to illustrate all the things that we want to talk about. So we have a couple of tables. So let's just say something as simple as that. And we're going to be doing a transaction. So we're going to create an order and create a shipping record. And of course, this is a simple SQL transaction. Therefore, these will happen together. So we'll say begin transaction. Here we go. Now this is very simple. This will happen atomically as a transaction. Now what happens if we break it into microservices? Let's break it up into two microservices. One handling orders, one handling shipping. Here are our microservices. Now there's lots of different ways of doing it. Please don't look at it as this is the right way or the wrong way. There's different ways of orchestrating distributed transactions. That's not important. We're going to be focusing on what can go wrong with the two transactions being done in two different systems. So what we're going to do first here is we're going to write into the order database. So now that we insert an order, now we have to create a shipping record. And of course, this is a different microservice, therefore it's not accessible. We cannot access this database. So one way we can do is we can perhaps create a REST interface. And what we would do is we would call this API. Of course, we're not going to call it insert into shipping. We're going to do something like that. But basically, we broke up the two-step process into an insert into a database and now an API call. Yeah, put it here. This is unfortunately how many services are made, and they're left at that. But of course, things can go wrong. What can go wrong here? Well, first of all, we know that this HTTP protocol can fail. We know that the HTTP protocol may fail for many different reasons, gateway errors, etc. And therefore, when you try to make an API call and you expect it to come back, it may not. So what can we do about this? Well, we can put maybe retries. And that's going to be our solution number 2. So far we had a solution number 1. Now we're going to say it's solution number 2. So here's our solution number 2. Basically HTTP REST calls, but with retries. So perhaps you do 3 retries. Every time you retry, you take a little longer before you do a next retry. Maybe you do 5, 7, 9. But you'll find that eventually you cannot do unlimited number of retries. And there will be situations where the shipping microservice may be down, such that no matter how many retries you do, you will not be able to complete the shipping. What that would mean is you're going to have an order, but no shipping, which means a distributed transaction broken. So maybe it doesn't happen that often, but it will happen often enough where it's going to become a problem. So what do? Let's replace it with messaging system. We'll call it solution number 3. So here we have a message queue. Rather than calling a REST API, we're going to create a shipping message. Again, there's many different ways of doing it. That's a whole conversation on its own. We don't care whether we're creating a message or an event. The point is that we're making some kind of an asynchronous communication between this order microservice and the shipping microservices. And we're using some kind of message queue, which provides a lot of fault tolerance. And then the shipping microservice will pick up that message, like so. And again, very often we stop here and we think that everything is okay. Well, things can fail here too. What can fail? Well, first of all, the picking up of this message can fail. So there are many different situations where this could happen, but for example, the shipping microservice may not be able to process this shipping message. There may be a bug, basically something different about that message where the shipping microservice fails. What will happen? Well, depending on the message queue technology you use, there's different ways of handling this. A common way of handling it for a lot of the message queue technologies is that messages that cannot be processed for a long time or for a specified time are put in something called a dead letter queue. Let's show that right now. So here we go. If a message cannot be processed for a long time, it will be placed in dead letter queue. Again, there's different ways of it happens in different ways, but something to this effect has to happen. You may think, well, why put it there? Why don't we leave and keep trying that complete message until it works? Well, if it cannot work because of some bug, and the message just keeps trying to be processed by the shipping microservice, then you basically have a failed transaction. You will create the order, but you won't actually ship the product. And you won't know that you haven't shipped it in an easy way because you will keep trying to actually ship it. So typically the way you would set it up is that after a certain amount of time, again, depends on your situation, could be minutes, could be hours, could be days, you put a message in that letter queue. So what do you do with that? Here we come to the next solution. What we're going to do is we're going to create a listener that listens for failed messages in dead letter queue and basically notifies support that, hey, we have a problem that we have to deal with. Okay, so here's our solution. Again, this may not be a support person. Maybe this is a system that automatically handles it, reverses the transaction, different things. It's not a problem. The point is to realize that even a message queue can fail, and it can fail in a way that the message gets moved to some kind of a, hey, I cannot process this message location or event or something of that sort, and we have to be able to handle that event. How we handle it is a whole different story, but you must be aware that this could actually happen. Now, you may be justified in thinking, Okay, we're done. We got everything fixed. But unfortunately, there are more problems. And again, you have to be aware of those. We're assuming that this message queue never fails. Does it never fail? Or are the situations where it fails? Well, maybe it's provided by AWS or Azure or something like that. And it's managed by somebody else and they promise high uptime. They do, but do they promise constant uptime? They never do. So what they promise is something like 9.9 uptime SLA. And you may think that's quite a lot. And it is. However, when you look at this, that's actually over 40 minutes of downtime every month. Now, that means for 40 minutes out of the month, your application, your transaction may fail. This message may not be sent to the message queue. But again, you may say, well, this will fail probably momentarily for a few seconds, maybe a minute or so. But I'm using this messaging queue and it provides me these lots of features where it ensures that a message will be sent. And here you have to really look into the documentation of your message queue technology that you're using. You have to look at what exactly does it do. You're probably using an SDK to send this message here. And the SDK will probably keep sending the message, keep trying to send the message if the message queue is down, basically implementing retries. However, there's always a situation where this actually sending to the message queue may fail. For example, if you're running this in Kubernetes and this order microservice is a pod, this pod may go down while the message queue is momentarily down and while you're trying to send the message here. The order microservice may be running, it may be trying to send, this is failed, and the order microservice may fail at that moment. When that happens, you will have an order, but no shipping. And again, often I hear, well, it will happen so rarely, we don't care about that. And if you are truly building in Amazon, and it happens, maybe you cornered the market, and you don't care that it happens to your customers as often as it does, and you can deal with it with using apology-based transaction consistency. So you basically apologize to the customer and you deal with it. That's one way of doing it. However, what if you're not building in Amazon.com? What if you're building a B2B system and your client is not Amazon, but a bank? Big, angry, rich bank. And they are sending you orders for, say, loan fulfillment or something like that. And the bank sends you an order to fulfill a loan. They register it as completed because you have created an order, but you actually haven't fulfilled the loan, whatever that may be. In this case, wouldn't be shipping something else. Well, that could become a problem because the bank may be sitting there for days thinking that the loan is being processed and it's not. And the result of that failure could be significant fines from the bank. You might have a contractual relationship that requires you to fulfill orders within a certain amount of time. If not, there may be contractual financial penalties. So this may become a problem. And you may ask yourself, can this be dealt with? Can we deal with the situation that message queue is down? Well, yes, we can. And that takes us to the next solution. Now, what if we developed our own persistent retry mechanism such that if this message queue fails, we will still be able to send to that message queue? Let's see how that would look like. What if we created a table that holds these messages and created a system which tries to send that message to the message queue, but keeps retrying if the message queue fails? So here it is. Now what do we do here? We create another table which holds the shipping messages that we are about to send. So the second part of the transaction. And now we insert into orders and we insert into the shipping messages table. Because this is a SQL call, we can wrap this in a transaction and this can happen. We know this will happen atomically. Then we'll have to build a listener, some kind of an application that will pick up messages that are unsent from this table, and it will try to actually create the message on the message queue. And if it's successful if it created the message successfully, then it will mark the message as sent. So the message will be either deleted or marked as sent, therefore will be not picked up again here. Now again, if you're looking at this and thinking, wow, this is an overkill, we have tool SDKs that can do it. That's not the point. The point is that I need you to know is that this can fail. The message queue can fail, and you must handle it in some way. And here is one possible way of handling that. Looking at this, you may think, well, surely we are done. Well, not quite so. Why? Well, what if the message cannot be sent to the message queue? And you wonder, well, how could that be? We're having this system that will do the retries. Well, what if the message queue actually checks for a schema, basically a structure of this message, and something in that message is not following that schema, and the message queue is not picking up that message, or this listener is down, or something like that. There are various situations where it could happen. It's a minor thing because you can get around it by, for example, making sure that the message queue accepts every message and does not check schema. So there's different ways of handling it, but we must be aware that even sending the message to the message queue can fail. And if you want to be double careful, you could put a listener Okay, here we go. We could create a dead message listener looking for shipping messages that are, for example, certain minutes, hours old that haven't been sent, and we can notify support saying, hey, something is wrong. Some shipping messages have not been sent. Again, there's many different ways of handling it. It's not the point how you handle it. It's the point that you have to be aware of the problems that may occur. Now you have a pretty robust system, and we're going to leave it at that. I will just mention one more simplification, and that's solution 6. The point is to understand what can go wrong and what the different technologies give you. If you just slap a message queue, it doesn't mean that you now achieved an atomic transaction. Things can go wrong. But solution number 6 is, well, if we have all of this here, do we really need the message queue? Can we simplify it? Yes, it can. We don't need the message queue at all. So here's how we can simplify the system. We can get rid of the message queue and all the technologies that it entails, and we can now have a REST API interface because we've built our own transaction system. Again, I'm not recommending that this is what you do, and the reason why is because this gets very, very complicated when you have more than 2 steps. The point is to realize that simply slapping a message queue in does not fix everything. And I want you to be aware of all the problems that are there and how they can be solved, either by building things on your own or using features of the tools that you're using that will achieve this kind of success.